Hello, welcome back to Algebra 1 with Miss Betsy. We are continuing our discussion today of dealing with polynomials, and today we're going to be subtracting polynomials. For our text that I'm using today to drive this video, it is the second edition of Algebra 1 for Christian Schools, published by Bob Jones University Press. Different ordering in the third edition. The page numbers, the chapter numbers are different, but the material that's covered is the same. You can use it with either text. You can use it with any other public school, private school text that you'd be using, because you're going to add and subtract polynomials in the same fashion. So let's go ahead and pray, see what our lame joke is, and get started. God, I thank you that you love us. I thank you for the beauty of the world that you've created around us and for the variety of the seasons. I thank you, Father, that you've given us the ability to learn and to understand things. Help us to be able to wrap our mind around this whole concept of algebra, and help my students on the other side of this computer to be able to understand and apply the concepts that we learned today. And I pray in the name of your Son, Jesus. Amen. Okay, I just finished lunch not too long ago, so this is quite apropos. What kind of seafood tastes great with peanut butter? I have to, I've been watching the show Chopped on TV, Food Network show, where they pair together all of these weird ingredients in a basket. And I wouldn't really think of seafood and peanut butter unless you're going to have it with jellyfish, and then it would work quite well. So what we are going to do today is we are going to be simplifying polynomials where we are being asked to subtract them. And our instructions here for this first example simply said, simplify 3x squared plus 2x minus 5 minus the trinomial 4x squared minus 5x plus 2. And what I'm going to do, the first part of this video, is show you exactly how they're using this in the text, and how a lot of other books will use, where they use the principle that subtraction is the same as adding the opposite. So what we're going to do first is for the first couple of examples, is we're going to see that we can solve the subtraction of polynomials by using the principle of adding the opposite. So we have this first trinomial. It's a trinomial because it has three terms, and it is a second degree trinomial because the degree of the highest degree of any term inside it is second degree term. Now, rather than subtract this second trinomial, we're going to add the opposite. When we take the opposite of this trinomial, what that has the effect of doing is the signs of every term in here change. They reverse. Because what we're doing is we're actually distributing a negative. So we have plus negative 4x squared plus 5x minus 2. Now let's make sure that I correctly changed the signs of every term in this trinomial. Positive 4, negative 5, positive 5, positive 2, negative 2. Now, all we need to do is remove the parentheses. 3x squared plus 2x minus 5 minus 4x squared plus 5x minus 2. And then what we are going to do is combine like terms. Okay? Like terms have to be the same in variable and in exponent. So we have two terms here that are x squareds. We have 3x squared minus 4x squared, negative x squared. Now we have two terms here that are x. Plus 2x plus 5x is positive 7x. And now we have our constant terms. And remember, constant terms are not showing a variable. We have negative 5 minus 2 is a negative 7. And this, then, negative x squared plus 7x minus 7 is the result that we arrive at when we subtract these two trinomials. So let's check and make sure that I haven't missed anything. And we have negative x squared plus 7x minus 7. And what we showed you here was just keeping those trinomials in a horizontal form. But you can do the same thing. You can take a problem and add the polynomials vertically, or put them in a column and line them up. So let's do our second problem in that fashion. Our example 2, section 8.3, subtracting polynomials. On page 330 in the second edition, we have simplify 5a minus 7b plus 6c plus 10, and then we are going to subtract 3a plus 4b minus 8c minus 9. We're going to subtract this whole entire polynomial here, so we have to make sure that we're enclosing that in parentheses. Now we have 1, 2, 3, 4 terms here. We don't have a special name for a polynomial that has a collection of terms that has more than 3 terms. So this is a polynomial. We know it is traveling together because it has those parentheses to say all of this group here of terms goes together. Now if we're going to add these two polynomials together vertically, we're going to remove the parentheses, and we have 5a minus 7b plus 4c plus 10. But we're still going to use the concept that subtraction is the same as adding the opposite. So we are going to add the opposite. We're going to look at our polynomial here, positive, positive, negative, negative, and we're going to add the opposite, or what we would call the additive inverse. And let me come back to additive inverse. So we have a negative 3a minus 4b plus 8c plus 9. Now I mentioned that term additive inverse. What exactly is it that I'm talking about when I say additive inverse? Well, you have a number, and the additive inverse is what's required so that when you add those numbers together, or those terms together, you end up with 0. You can think of them, they make each other disappear. The additive inverse of a positive 3a would be a negative 3a. So additive inverses are opposites. Now in our pre-algebra class, we're still struggling to learn the difference between opposites and reciprocals. We have opposites here, positive 3, negative 3. The inverses would be 3 and 1/3. So when you add the opposite, you're really adding the additive inverse. Just a little bit of vocabulary refresher here. So now we have changed our subtraction problem to an addition problem, and now we're simply going to add the columns. However, I'm looking at the answer and seeing my answer is not going to agree. Remember what I've said, make sure that you copy the problem correctly. Do you see the error that I have here? 5a minus 7b plus 6c, I wrote down 4c. Make sure that you take the time to verify that you've transcribed the problem correctly. 5 plus a negative 3 is 2a. Negative 7 plus a negative 4 is minus 11b. 6 plus 8 plus 14c, 10 plus 9 is plus 19. And this polynomial here you can check at the bottom of page 330 and verify that this 4-term polynomial is the result of subtracting this polynomial from our first polynomial. Now, let me go ahead and do their last example in here, and I'm going to show it two slightly different ways of thinking. One of these may resonate with you. Use whichever one makes most sense to you. If it doesn't make, if there's no difference, then use whichever one you've been using. How's that for an articulate comment? Okay, we have 4x squared plus 3xy minus y squared. And then we are going to subtract from that the trinomial 5x squared minus 8xy plus 4y squared. Let me take the time to make sure I've copied this correctly. These glasses do not always cooperate on me. 4x squared plus 3xy minus y squared minus the trinomial. It's a second degree trinomial because the highest degree term, as a matter of fact, the degree of all three of these terms is a 2. So this is a second degree trinomial. 5x squared minus 8xy plus 4y squared. So what I'm going to show you first is how we change our subtraction problem to an addition problem. And I'm going to do this vertically. And I have 4x squared plus 3xy minus y squared. And now we're going to add the opposite. We have a negative 5x squared plus 8xy minus 4y squared. And then we're going to add these in vertical fashion. Negative 5x squared, positive 8xy, negative 4y squared. 4 plus a negative 5, we have a negative x squared. 3 plus 8, we have 11xy. Negative 1 plus a negative 4 gives us a negative 5y squared, or minus 5y squared. Let me just take a quick glance here. Okay. Now, what we did here was we changed the subtraction problem into an addition problem, and we're allowed to do that because we have learned that subtraction is the same as adding the opposite. But what if we just wanted to subtract? Some of you have learned to be very comfortable simply with subtracting negative numbers without converting to this adding the opposite. Let me show you what I mean. It's going to look exactly the same. We have 4x squared plus 3xy. And I'm going to move that. Oh, what a mess. Let me erase that. We have 4x squared plus 3xy minus y squared. And now I'm just going to put my little reminder here that I'm simply subtracting. What am I subtracting? I'm subtracting this trinomial. So I want to subtract 5x squared, the entire trinomial. All I'm doing is copying it exactly. And at this point, you compare our two problems here. And there's a very clear difference in their appearance. But it's going to come out to be the same answer. Because as you have gotten to be, as you've progressed to the point where you're comfortable adding and subtracting negative numbers, you can simply subtract. 4 minus 5 is a negative 1, so we have a negative x squared. 3 minus a negative 8, we're going to add that becomes 11xy. Negative 1 minus 4 is a negative 5y squared. If I can write my exponent where it belongs, negative 5y squared. So you look at our two solutions here, they're identical as they would need to be. Whether you simplify this problem that involves polynomials by adding the opposite of the second polynomial, or whether you simply directly subtract, I don't care. Whichever makes the most sense to you. Let me speak this again here. We're simply going to subtract what is inside the parentheses here. We have 4 minus 5 is a negative 1. 3 minus a negative 8x squared, negative 8xy minus a negative is the same as addition. 3 minus a negative 8 is 11xy, plus 11xy. Negative 1 minus 4 is a negative 5y squared. Some of you, your terminology, the way you've been taught is a little bit different. Both of these are equally legitimate, totally acceptable ways of solving problems where you're dealing with positive and negative numbers or positive and negative algebraic terms. That's really all that there is involved in section 8.3. Again, what's going to trip you up? It's going to be dealing with these negative signs. It's going to be dealing with, as we had some examples in the prior video for adding polynomials, where you might be missing a term and you have to add, make sure that you only are lining up vertically like terms. They have to have the same variables and the same exponents. Okay, and what I'm going to do now is erase everything except two terms here, just to illustrate what I'm talking about, where you're going to just have to be really careful that you don't get tripped up. And this happens very, very commonly. Let me grab my other black pen. I have a negative 8xy, I have a positive 3xy, but I'm going to change this now to okay. You glance at these, and if you're not really careful to be precise and realize what's going on, you're going to think these are the same terms. We've got an x and a y and it's squared. But look at this, we have an x squared and an x to the first. We have a y, and then we have a y squared. These are not like terms, because the exponent that is the same has to be attached to the variable that is the same. So your temptation here, if you have these two terms in the midst of polynomials that you're adding or subtracting, your temptation is going to be to do 3x squared y minus 8xy squared. And you would miss that these are not like terms. So what you would have, to make it screaming obvious to you, you have 3x squared, and then you have 0, let me use this brown, because I really want to take a second to make this point obvious. If we wanted to combine these two, we have 3x squared y plus 0x squared y minus 8xy squared. How many xy squared terms do I have over here? I don't have any. Plus 0x squared y. And then you see that you cannot simplify these because they are not like terms. And you may be looking at this and saying, duh, Miss Betsy, this is really obvious and I already knew that. But this is the sort of thing that you get going on this roll and say, you understand, I'm going to da-da-da-da-da-da, and then it'll trip you up. So don't be afraid to use zero placeholders if you need to. And also don't get going so fast, don't get being so cocky here that you miss something because you're in too much of a hurry to be careful and to pay attention. So I hope that's been very helpful to you, and I will see you next time.